Now let's learn about compounds, some commercially important compounds of calcium. Compounds of calcium. Number 1 in the list is quicklime. Quicklime, the composition, the formula is calcium oxide, CaO. It is obtained by heating limestone. On heating limestone, you get calcium oxide and carbon dioxide. We have also already discussed about this reaction. This reaction is reversible. If you heat calcium carbonate, you get a mixture of calcium oxide and carbon dioxide. These two are complementary in that this is basic and this is acidic oxide. There is a possibility of these two again combining to give back calcium carbonate. So the best way is to exploit this fact that these two substances are solids and carbon dioxide is a gas. Allow carbon dioxide to escape out. When carbon dioxide comes out, this reaction can be driven in the forward direction. So this is how quicklime is obtained. Remember this feature of quicklime, it is capable of absorbing two substances from air. Absorbs a moisture. So this can be used as a desiccant or drying agent. It absorbs moisture. Apart from this, it can also absorb carbon dioxide. It is capable of absorbing carbon dioxide. You can see it can react with carbon dioxide to give back calcium carbonate. So it is capable of absorbing two substances from air, that is moisture and carbon dioxide. This property is exploited in using calcium oxide for drying gases. But remember, you cannot dry acidic gases using calcium oxide because calcium oxide is itself a basic substance. So it is specifically useful in drying ammonia gas because ammonia gas is a base. So it is used in drying ammonia gas, ethyl alcohol, you call it ethanol, etc. So if you pass ammonia gas through calcium oxide, it will lose all its moisture and becomes dry ammonia gas. Even ethanol can also be distilled. Rectified spirit can be distilled with calcium oxide, quicklime, and you get absolute alcohol. Another important use of calcium oxide is cement. In the manufacture of cement, almost 50% of cement consists of calcium oxide. So this is a substance. Limestone and clay are mixed and heated, and then later gypsum is added. This mixture is it is called as cement, right? And then it is a source of, I can say it is a source of base, cheapest source of base. If calcium oxide is mixed with water, it is called as slaking, and you get slaked lime, and slaked lime has several commercial uses. So it can be used in the preparation of slaked lime. So this is the information regarding quicklime. Quicklime is obtained by heating calcium carbonate, that is limestone. It is capable of absorbing moisture as well as carbon dioxide. It is therefore used in drying ammonia gas, ethanol, and other substances which themselves do not react with calcium oxide. Calcium oxide, remember the nature of calcium oxide is basic. Well, the next compound of calcium is calcium hydroxide, which is popularly called as slaked lime. Next one we are going to discuss is slaked lime. Chemical formula of slaked lime is calcium hydroxide, CaOH, taken twice. As I told you, this is obtained by mixing water in calcium oxide. You end up with calcium hydroxide. Here you should remember that suspension of calcium hydroxide is called as milk of lime. Suspension of calcium hydroxide is commercially known as milk of lime, and clear solution of calcium hydroxide is called as lime water. Clear solution of calcium hydroxide is called as lime water. Lime water is specially used for testing carbon dioxide in qualitative analysis. When carbon dioxide is passed through lime water turns milky. The reaction involved is CaOH taken twice reacts with carbon dioxide. You get a white precipitate due to formation of calcium carbonate. Of course, water is formed. So you get a white precipitate due to calcium carbonate. Here, care has to be taken. If you pass, continue passing carbon dioxide for longer period, you end up with calcium bicarbonate. You once again get a clear solution. This is soluble substance. So if you are testing carbon dioxide, see to it that you pass limited amount of carbon dioxide through lime water, then only you get a white precipitate. But prolonged passing of carbon dioxide gives clear solution of calcium bicarbonate. All bicarbonates, you know, are soluble in water. Now, few uses of calcium, few reactions of calcium hydroxide. Calcium hydroxide, when it reacts with chlorine, chlorine undergoes disproportionation, and you get a mixture of calcium chloride plus CaOCl taken twice, of course, water. This is calcium chloride where oxidation state of chlorine is -1. This is calcium hypochlorite where oxidation state of chlorine is +1. So in this reaction you can see the same element chlorine has changed its oxidation state from 0 to -1 and 0 to +1. It's a case of disproportionation of chlorine. This substance is an essential component of bleaching powder. Now coming to uses of calcium hydroxide. Number 1 is in the manufacture of bleaching powder. Calcium hydroxide is used in the commercial production of bleaching powder. Next is it is used in whitewashing. It is used in whitewashing. These are two important commercial uses of calcium hydroxide, which is popularly called as slake lime. The next compound of calcium is CaCO3. It occurs in different forms naturally, as marble, as chalk, or limestone. These are different forms of calcium carbonate available naturally. It can also be obtained like this. If you react calcium hydroxide, that is slake lime, with carbon dioxide, you can get calcium carbonate. This is one way of getting calcium carbonate. Of course, you get water molecules. Apart from this, if you react calcium chloride with sodium carbonate, a precipitation of calcium carbonate takes place. CaCO3 plus 2NaCl. This is a laboratory method of preparation of calcium carbonate. Regarding reactions of calcium carbonate, CaCO3, when it is heated, you know very well, it gives calcium oxide and carbon dioxide. This is one reaction. Even, you know, CaCO3, if you react with any mineral acid, say sulfuric acid, hydrochloric acid, any mineral acid, it will produce carbon dioxide gas. Any acid which is stronger than carbonic acid on reaction with any carbonate salt will produce carbon dioxide gas. So you get CaSO4, water and carbon dioxide. Its most important use is it acts as a source of carbon dioxide, and it acts as a source of calcium oxide, which I said is the cheapest available base, calcium oxide. So that's about calcium carbonate, which is popularly called as limestone.